Good morning or afternoon, depending on where you're joining us from. I'm Dane Christensen, Digital Marketing Manager at GridGain Systems. I want to thank you all for taking the time to join us today for this very informative webinar on Apache Ignite. Your presenter today is Dmitry Setrekin, who is founder and VP of Engineering at GridGain Systems, as well as the chairman of the Podling Project Management Committee for Apache Ignite. Dmitry has over 15 years of experience developing distributed computing systems, middleware platforms, financial trading systems, CRM, applications, and similar technologies, and certainly one of the foremost authorities in the field of vast data. But before we get into Dmitry's presentation, I have just a few quick administrative points to make. Dmitry will be speaking for about 35, 40 minutes, after which we'll have about 15 minutes for Q&A. You'll notice that just above the presentation screen is a questions button. Click there to ask any questions that you have at any point during the presentation. And Dmitry will respond to your questions during the Q&A segment. Now, we may not have time to get to all the questions during this event, but we will definitely answer them all afterward. So please take advantage of this opportunity to ask questions from an expert in the field. Also, I wanted to make sure you are aware that we've included some additional resources in the attachments area, including the Apache Ignite white paper, a link to an interview with Dmitry on Apache Ignite, a link to the official Apache Ignite website, and of course, a PDF of today's presentation. And finally, please also notice the rating button right next to the attachments. We'd appreciate any feedback you can provide us so we can continue to improve on our presentations in the future. So with that, we're ready to turn the floor over to Dmitry Setrekin. Dmitry?
Yes, hello everyone. Thank you, Dane. There were some minor audio issues when Dane was speaking, so I hope those issues go away when I talk. Also, I'm hoping that we will resolve some screen sharing capabilities with BrightTalk throughout this presentation. So if it's possible, I will do some screen sharing as well. If not, I will just take you guys to slides. So again, I'm Dmitry. I'm one of the founders at GridGain Systems. I also run the engineering there, and I also preside on PPMC committee for Apache Ignite project, which is undergoing incubation in Apache. So what we're going to talk about today is we briefly will touch on what in-memory computing is and why Apache Ignite is what it is, what kind of components it provides. We'll talk about clustering, DataGrid, compute grid. There's the service grid, which is a very cool component that we've added. There's streaming, and I kind of will touch on Hadoop accelerator as well. And then if we can share screen, I can show some coding examples. Otherwise, we will just move to Q&A. So let's take a look at what in-memory data fabric is, and essentially what Apache Ignite is, what Apache Ignite in-memory data fabric, and why this strategic approach for your in-memory computing needs. So essentially, when you actually moving into in-memory computing, you actually plan to introduce some distribution into your cluster, into your deployment. You plan to introduce some scale-out features. At some point, you will probably introduce some distributed computation capabilities, distributed clustering capabilities. You will need to stream data into the cluster. You will need to process that data. You will need to query that data. Potentially, you may even have to store files in a distributed fashion, in a distributed file system. So all those features are important when you actually move into in-memory computing and when you move into distributed architecture. A lot of times, in-memory computing is associated with distributed architecture, with scale-out architecture. So, or usually when you were faced with all these challenges, you probably would end up looking at 4 or 5 projects available and then start comparing vendors and providers in every field and go through painstaking integration process, etc. And that's exactly what we try to avoid when you come to use in-memory data fabric. So when you use Ignite, you get all these components under umbrella of one project, under umbrella of one product. All these components are independent. For instance, you don't have to use all of them. You can just use one of them. For instance, you can use Ignite just for clustering capabilities, it has a pretty cool clustering. I'll talk about that. Or you can actually use more than one component, in which case you take advantage of the integration between these two components. For example, if you integrate compute with caching, then compute will always know where to route the computations to. Same goes for streaming, same goes for file system, etc., etc. So that's why Ignite Data Fabric becomes a strategic approach, because it actually is meant to become one-point stop for most of your in-memory computing needs. But despite all this breadth of functionality, in-memory the fabric is actually very easy to use. Ignite comes as a zip file. If you download binaries, you can also, of course, download source code from Apache. But if you download binaries, Ignite comes as a zip file, which you just unzip and use. It has one dependency only, one mandatory dependency, which is Ignite core jar. You can bring other dependencies a la carte. Ignite is fully Mavenized, so you can actually add dependencies as you need them. In a binary form, you would just drag and drop a jar file from one folder to another, and it becomes utilized. So, for instance, let's say you want to add, you want to start using Spring annotations for caching, or you want to start using Spring IOC format for XML configuration, for instance. You would just bring in a Spring dependency on a la carte basis. Or if you want to start doing log4j logging, if you want to Ignite to utilize log4j instead of Java logging, you would bring log4j dependency, etc., etc. So dependencies can be brought a la carte. And all of that is actually done to make sure that Ignite is very easy to get started with and very easy to use. It also utilizes most common Java data structures in distributed format. For example, we took standard Java maps, sets, queues, executor service, and the whole atomic Java util concurrent package, and we actually made it distributed. So whenever you use Ignite APIs, you will see lots of common data structures that you already know how to use. So from that standpoint, the getting started path is also should not be too painful. And another cool thing about Ignite is that it can run on any hardware. You can deploy it on your laptop. You can deploy it on any commodity Linux blades. It does not require any. It does not have any hardware requirements. The only thing we require is that you have Java pre-installed. So let's actually take a look at, in some detail, at what components Ignite provides. And this slide actually says it's more than a DataGrid. And the reason we say that is because we get compared to DataGrids a lot, because there are some DataGrid vendors on the market. And granted, DataGrid is one of the biggest components in Ignite. But I would argue it's equally important as compute grid, as service grid, as streaming capabilities, as file system, etc. So for those who do not know what DataGrid is, it's a distributed cache with extra features. It's a cache that allows you to query the data in memory in a very complex, in many different ways. It allows you to transact on that data. It allows you to store it on heap and off heap, etc., etc. But there is also compute grid, which allows you to distribute computations and compute in parallel within your cluster. And if it's used with DataGrid, computations will be distributed to the nodes where the data is. But cool thing about compute, it can work with or without data. It can work with data stored in some third-party storage. So Ignite doesn't care where, from a compute component standpoint, Ignite doesn't care where the data is stored. But at the same time, you take you benefit from in-memory map reduce and fork join APIs on compute. You benefit from load balancing, fault tolerance, and a lot more. There's also service grid, which essentially I like to qualify it as singletons on the cluster. It gives you a way to deploy all sorts of singleton services in the cluster. And it's a pretty cool feature, fairly unique to Ignite, but I'm noticing that more and more users actually take advantage of it on a daily basis. Streaming, the streaming component that has to do with streaming data into Ignite and querying it in a sliding window fashion. I'll talk about that. There's a file system, which is a distributed Hadoop compliant file system. So you can actually use it to replace HDFS or to write through to HDFS. You can put it on top of HDFS and use it as a caching layer. But it's fully Hadoop compliant, so you can plug it into Hadoop deployments and use it in that fashion. And there's also Hadoop Accelerate, which is also plug and play and accelerates Hadoop file system and Hadoop MapReduce execution. All right, so let's take a look at clustering. So when we talk about clustering, it is very important. Clustering is one of the backbones of any distributed architecture. It's almost a spinal cord of distributed architecture. And it's very important that it's very flexible. You never know which deployment you're going to be started in. Users may start Ignite on a laptop. They may start Ignite on Amazon Cloud, on private cloud, or maybe in a hybrid approach with part running in public, part in private cloud. So all these environments have actually different they support different way of starting the cluster. They have different limitations, so to speak. For example, you cannot use multicast in AWS cloud, or TCP IP addresses always change usually in public cloud. So it is very important that a clustering component can automatically be brought up in all these environments. And Ignite, if you download Ignite or look at its APIs, you will notice that it's completely pluggable. All main components in Ignite are pluggable. And node discovery is one of those pluggable components. And it has several implementations. We have a multicast-based implementation. We have TCP-based implementation. And even for Amazon, we have S3-based implementation, where nodes, when they are brought up, they register their cloud coordinates, so to speak, with S3 storage. And other nodes can see them, and that's how discovery happens. There's also a pretty cool feature in Ignite called zero deployment. So once you actually started your cluster and all nodes have discovered each other, you can start throwing computations onto the cluster without actually having to explicitly deploy them. And I always say use this feature in development. In production, generally, in production, it may not be such a good idea because you don't want any magic happening in production. Generally, in production, you want to make sure that you always want to know what gets deployed where. But during development, you constantly change your code, and redeploying it on the cluster every time you change it may become painful. So there are no zip files to deploy, no jar files to copy. You can just write your code or hit a run button in IDEA or Eclipse, and it will automatically execute on the cluster. So this screen actually shows how nodes are started and discover each other. Essentially, in a bin folder under Ignite installation, there is a Ignite DataStage script, or used to be called ggstart script. And if all you do is you execute that script. And by default, Ignite will discover other nodes using multicast. So if you have multicast enabled, everything should just work with zero configuration change. So all you need to do is execute that script more than once, and you will see that nodes will automatically discover each other. And the printout, how you know that they discovered each other, they print out the number of nodes in a console window. So in this example, both nodes are printing out that there are two nodes in the cluster. So let's take a look at Ignite DataGrid. As I mentioned before, it's one of the main components of Ignite, and generally, it's probably one of the most used components of Ignite. Not to say that other components are not used, but they're usually used in conjunction with DataGrid. A lot of times they're used in conjunction with DataGrid. So again, for those who are not familiar with what DataGrid is, most of the people are, I'm noticing, are familiar with what a distributed cache is. And DataGrid can be viewed as a distributed cache. For instance, Ignite DataGrid is a distributed key value store. And it works in two main modes of operation. One is partitioned, and another is replicated. And I'll start with partitioned because it's the most scalable approach. And think of partition mode as a little bit of a different way as sharding, from sharding. So whenever you do sharding, you actually assign ranges to keys, and you say key from range A to B, A to C will be stored on this shard, then from G to F will be stored on that shard, etc. So essentially, the same kind of partitioning happens in Ignite when you utilize partitioned caches, except that you do not have to do any assignments, explicit assignments of key ranges. Ignite will automatically assign keys to partitions. That's why it's called partition cache, not sharded cache. Keys to partitions, and every cluster member will be responsible only for a certain number of partitions. So there is a concept of data ownership for a cluster member. You have 10 nodes in the cluster. Every node will be storing 1/10 of the data. So the more nodes you can add to the cluster, the more data you will be able to cache in a partition mode. This approach is very scalable. Why? Because essentially, since there's a data ownership concept, and in Ignite we call a node who owns a certain data a primary node for that data. And so whenever you you have to update that data, the only node you have to contact is a primary node for that data. So regardless of how many nodes you have in your cluster, you may have 10 nodes, you may have 20, 100, or 1,000. If you execute an update, you are only updating one node. In a purest form, of course, there is a redundancy, and you may configure backups, and then you will be updating primary node and as many backup nodes as you configured. But generally speaking, that is not dependent on the amount of nodes you have in the cluster. So that's why this approach is very scalable. Writes are extremely fast. Reads are not as fast because now data is not available on every cluster member, and you may have to go and fetch it. But in Ignite, that problem is usually solved with near caches. So clients actually have their own what we call near caches, which cache most recently accessed data by those clients. So in that sense, in combination with near caches, this approach actually becomes the most performant and more scalable approach. So that was for partitioned caches. There's also a replicated cache, which can be viewed as a special case of a partition cache, where each key is backed up, has as many backups as there are nodes in the cluster. So if you view it that way, then every node becomes absolute copy of every other node. So the data cached on every node is identical. There's no real data ownership, but the data is available on every cluster member. In that case, wherever you go, the data will be there. But also with this approach, updates become more expensive because now you have to, with every update, you have to update all cluster members, all nodes in the cluster. And another deficiency of this approach is that you can only store as much data as can fit in one node in the cluster. If with partition caches, the more cluster members we added, the more data we could cache. With the replicated caches, it doesn't matter how many cluster members we add, we only cache as much data as can fit on one. However, replicated caches are still utilized quite a lot, especially for not so large or read mostly data sets, and they're used usually in conjunction with partition caches. You can actually pick and choose how many partition or replicated caches you may wish to have, and then you can cross query between these caches, you can cross transact between these caches, etc. So that brings me to to transactions. Ignite, one of the differentiating points for Ignite is lightning fast transactions. From what we hear from our users, we have one of the fastest transactional implementations on the market today. We do, and we achieve that by because of several things. Mainly, we started out as a transactional cache, and even though we utilize two-phase commit, there are plenty of one-phase commit optimizations that get used when working with Ignite caches. As a matter of fact, majority of the time when you use Ignite cache, you will be using one-phase commit optimization rather than two-phase commit transaction. And we also have a lock-free MVCC-based concurrency control, which essentially allows us to efficiently keep track of multiple versions within the cluster at the same time without doing any locking. So all of that in combination make a very fast transactional engine that is provided in Ignite. Another the differentiating features of Ignite DataGrid is that you can actually use standard SQL queries against your in-memory data. And these SQL queries can be written in ANSI 99 compliant fashion. So essentially, I've seen people writing queries like 3-4 pages of queries on top of Ignite with queries doing nested selects, joins, inner joins, outer joins, unions, custom functions. You can actually add custom store procedures in Ignite, and which you can write in Java and use in SQL. So from a SQL standpoint, you have a fairly rich feature set, which becomes a very strong integration point, because usually when you start using a product like Ignite, you already have a lot of SQL that you do not want to migrate, and Ignite gives you ability to just take it and use SQL as is, and you immediately get benefit from distributed data and querying in parallel. So, and queries are also very fast. All the indexes are also kept in memory. So instead of caching query results, you can continue re-querying the same data set, and the results will be returned very fast, almost momentarily, because all the indexes are available locally in memory as well. And another thing I want to mention about DataGrid, which is very important, is OffHeat memory support. Essentially, if any of you have worked with Java heap spaces, and whenever you try to allocate more than 10 GB of RAM to Java, you probably run into garbage collection, GC issues. No matter how much you tune your garbage collection, you may postpone a large GC pause, but it will still come. Maybe it will come in 24 hours, maybe in 48, but it will still come. And it may take 5 to 10 minutes to clean up a heap space as large as 50 gigabytes. And whenever it comes to distributing data in memory, you are going to need large heap spaces. And it becomes very important to be able to essentially kind of cheat JVM into thinking that it does not have as much heap as is actually being utilized. And that's what OffHeat memory is for. Whenever you use Ignite with OffHeat memory, you would just allocate as much heap to your your JVM as required by your application. Forget about cache, just for your application. So usually that would be maybe 8-10 gigabytes of RAM, and then you can allocate 200-300 gigabytes of RAM to Ignite. And JVM will never know about that memory. Will never be, so you will never take a garbage collection penalty for having that much memory. At the same time, the data is still cached in memory. The data is still just a pointer access away, and you can still transact on that data. You can still query that data. One of the differentiating features here is that even query indexes are kept off heap. Just think about it. If you have, usually indexes take up about 20% of the overall data space. And that goes for disk-based and for memory-based approaches. So if you have about 100 gigabytes of data, your indexes will occupy about 20, maybe 25 gigabytes in memory. And with that, you already cannot use heap-based indexes, because 25 gigabytes of memory will introduce probably 2-3 minutes of garbage collection into lifetime of your application. And when I say garbage collection, I literally mean log the world type of garbage collection pause. It's when every node freezes and all it's doing is collecting garbage, and it becomes inaccessible to your clients. So no, business stops essentially. So it's a very bad thing when that happens, and generally people want to avoid it. So that's what OffHeat is for. It's available as a part of Ignite. If you look at other data grids on the market, you'll see that most of the projects do not provide it as an open source feature. They provide it as an enterprise feature, as a commercial feature. In Ignite, you can get OffHeat Memory as an open source feature and use it pretty much once you download Ignite right away. It's just one configuration flag. Same APIs, you don't have to code to it specifically. You can start coding to using OnHeap and then flip a configuration flag, and all of a sudden now you're using OffHeap storage. So it's very easy to switch back and forth as well. And of course, one of the main features of DataGrid is integration with Compute Grid. So even though you may not think, okay, all I need to do is just cache data in memory and I need to access that data in a performant fashion, you are going to be computing on that data. And collocation of compute with data becomes very important. And being able to collocate with multiple caches at once and being able to collocate not on the whole key set, sometimes it's not even possible to collocate on the whole key set, on a partial key set, on a majority key set, that also becomes very important. So if you think about Compute Grid, it actually took the same approach to computations as DataGrid took to partitioned caching. So in partitioned caches, we actually split the data into multiple pieces and assign those pieces to individual nodes. In Compute Grid, what we do is actually we take a computation, split it into multiple pieces, and execute each computation on an individual node. So it's a pretty similar approach. It's been called different things. It's been called MapReduce. It's been called fork join. I actually, in Ignite, you have a strong support for fork join paradigm, which is a special case of MapReduce. And in the special case, the mapping and the reduction happen on the same client node. When it comes to in-memory computing, this is the most utilized paradigm out there. It's usually a huge overhead and inconvenience to deploy multiple mappers and multiple reducers onto in-memory cluster. However, if you do mapping and reducing on the client side, it becomes very fast, very scalable, and you can actually process at that point thousands upon thousands of computations per second. So MapReduce is very good for batch-oriented processing, where you take something and run it for several hours. And that's why it's utilized in Hadoop, because it can accelerate those type of processes. But whenever it comes to sub-second computations, or maybe several second computations, fork join approach becomes much more scalable. There's also a lot of stuff that happens underneath. You can, there is load balancing, there is fault tolerance. As a matter of fact, Ignite Compute Grid comes with a guarantee that as long as there's one cluster member standing, no job will be ever lost. So jobs will be constantly failed over until they get a chance to successfully execute. There's also checkpointing for long-running jobs. For instance, if your job gets failed over and you don't want it to have to restart from scratch every time there is a crash, you can restart it from the last saved checkpoint. The load balancing is actually adaptive, so you can actually have your load balancer listen to the cluster and always pick the least loaded node. And it picks it based on looking at CPU, heap, network utilization, and many other parameters that you provide. So as I mentioned before, there's also, Ignite also has a pretty cool component called Service Grid. It's fairly unique to Ignite, but it's very useful. I'm noticing that it's becoming probably one of the most popular components within Ignite. And gets utilized a lot in conjunction with DataGrid. And if you look at the service grid, if I had to describe it, essentially in one sentence, I would say its ability to have singletons on the cluster. And by singletons, you can have different types of singletons. For example, if you look at this picture, the picture on the left shows node singleton, in which case every node has at most and at least one instance of that service deployed. So whenever new nodes pop up in a cluster, they already have that service deployed on that cluster. Or if you look on the right, it has a picture called cluster the picture shows cluster singleton, where only one node within your cluster will have a certain service deployed. However, if that node will crash, the service will automatically immediately pop up on another cluster node. So it's essentially continuously available. It ensures continuous availability of your service, regardless of changes in your network topology or in your cluster. And service can actually be something very simple. It can be just a counter you update on the cluster. It's just very simple API you deploy, and it will be and Ignite will make sure that that API is continuously available. So apart from cluster singletons, you can also say that I may wish to have more than one instance of a service deployed on a cluster. Maybe you have a cluster of 10 members and you want to deploy only 3 instances of the service, one on each on different cluster member. So you can do that too. It's a custom topology deployment. And Ignite will make sure that those instances of your service are deployed in a load balanced fashion. So very cool feature. Please do check it out. I'm pretty sure you'll find a use for it in your application. And another fairly important component that Ignite provides is streaming. And when we talk about streaming, there are actually a couple of main use cases that are available when it comes to streaming. One is being able to workflow an event through a cluster, having each cluster member process certain type of events. It's an event workflow, and this use cases are generally covered. This use case like this is generally covered by a product like Storm, for instance. But another use case is a CEP, complex event processing use case, and that use case has to do with ability to have sliding windows and querying into those sliding windows. Just think about it, like streaming data is continuously pumped into your system. It never ends, right? Streaming data never ends. So it keeps coming, and you never want to query to the beginning of the stream, as it may actually be 1 month ago, maybe 1 year ago. You generally want to query into some window of the stream, maybe last hour, last week, or maybe you want to query each day individually within last week for the past week. So it allows you to do all sorts of the sliding windows approaches, and it allows you to utilize SQL when you query when you're querying your stream data. So Ignite has a very cool streaming API, and once you actually use that, once you actually stream data into Ignite, you are able to query it using standard SQL. And we're actually working on adding more streamers, what we call like more integrations with other projects on the market. For instance, there's a open Jira ticket in Ignite for integrating with Kafka. There's a Jira ticket for integrating with Storm. There are a few others about streaming. So it's actually would be a very good place if you want to get involved with the Apache Ignite community. This would be a very good place to start. It's not too complex and yet not too simple of a task, and definitely would add overall value to the overall Ignite offering. So definitely check it out. So lastly, I want to do a bit of a so-called marketing slide. If you're familiar with Apache Ignite, then you probably know that there is a product called GridGain, which provides enterprise features on top of Apache Ignite. And I think I actually covered quite a few features within Apache Ignite, and you can actually see that it is a fairly feature-rich project. In many cases, it can be used on its own as a standalone open source project. And we actually take very good care of our releases. Our releases come with good quality. We're one of the, if not the only one, project in Apache that actually has a QA team working on Apache Ignite and contributing testing time to Apache Ignite. So the open source project is fairly feature-rich and it's fairly well tested. However, when it comes to enterprises, you may need additional features. For example, what if you deploy multiple data centers? How do you replicate across those data centers? What if you need security or authentication or authorization or multi-tenancy? What if you need rolling upgrades? For example, if you want to upgrade Ignite to a new version, what if you don't want to restart your cluster, or you want to change classes on demand throughout the runtime? You do not want to restart your cluster either. So all this high availability and WAN type replication features are available in GridGain Enterprise Edition, and of course, together with various support options. And another feature available in Enterprise Edition is our Visor management and monitoring console. So if you download Apache Ignite Open Source Edition, you will get Apache Ignite from Apache Ignite website. You will get the management console, command line management console, which is decent. You can quickly check on live status of your cluster. You can check what's going on, what is the load across multiple nodes, etc. But if you want to visualize it, then GridGain comes with a GUI-based management console for Apache Ignite as well. Probably about 15 different screens there, all for different purposes. You can look at different configurations, start and stop nodes, view logs, take thread dumps of those nodes. You can even use SQL queries to query caches from Visor management. So it's a fairly rich management tool that definitely adds value in your projects. And with that, I actually was hoping to do coding examples, but I found out today that we're not going to have ability to do coding examples, so we'll probably do another webinar, and we will dedicate it to coding examples on Ignite, so probably within a couple of weeks. So stay tuned for that. And with that, I actually am going to move into Q&A and ask if there are any outstanding questions.
Yeah. Hey, Dmitry, we do have a bunch of questions, so it's probably just as well that you've ended a few minutes early, because there are a lot of questions from the attendees, and I'm going to go ahead and read those out to you. Now, there's actually a few people who've asked this same question, so I'll go ahead and start with that one, and just kind of summarizing the different folks who asked that. Basically, they're asking, how is Ignite different, or how does it compare to Apache Spark?
All right. Yeah, not the first time I'm hearing that question. And what I usually say is, I mean, there's two different products. Apache Spark is a very good product, but I think the use cases covered by this product are a little different. If you look at Apache Spark, it provides a very good computational engine on analytics. So it mostly deals with a read-only data, with event-based data that gets copied into Spark, and then you run analysis on that data. It actually also has machine learning. It has also streaming capabilities. So there's some overlap, but it mainly has to do with analytics. Ignite, for instance, on the other hand, can do both analytics and transactions. It may not. So, for instance, Spark has machine learning. There's no machine learning in Ignite, but there's still SQL capabilities in Ignite, so which you can utilize for data analytics and data queries. But at the same time, Ignite does not require that you copy data from one place to another when working on with Ignite. So you can actually do transactions in Ignite under high volumes, hundreds of thousands of transactions per second, and at the same time do analysis of that data, do queries of that data, and respond to some questions on that data on the same system without having to copy it anywhere. So I would say that Spark is probably a little bit more feature-rich when it comes to OLAP, analytical processing, and Ignite is probably a little bit more feature-rich when it comes to transactional processing, but both products do support analytical processing as well.
Great. Thanks, Dmitry. And here's another question. Is there performance comparison between Ignite and Zookeeper concerning simple read-write, and then in parentheses, to GridGain file versus Zookeeper node?
So I haven't looked at Zookeeper in a while, but from what I remember, I think it used a quorum-based approach. So you actually select a majority, and in that point you vote for get to vote for reads and writes. And I could be wrong, so if I'm wrong, don't hold it against me. I will deny it in court if it ever gets to it. In Ignite, reads are, as I mentioned, and writes usually have to go to one node, a primary cluster member. So I would say that Ignite probably would perform better. And Zookeeper is mostly used for resource management. Ignite is used for high volume transactions and processing. So with Ignite, you can actually achieve loads of hundreds upon hundreds of thousands of transactions per second. And by the way, we are going to be publishing benchmarks, so stay tuned. We will be publishing benchmarks against various other products that are available on the market, open source, and maybe some commercial if they will allow us, but definitely against open source. So I will blog about it, I will tweet about it, and we actually may also have another webinar to show how to benchmark a distributed system, which probably would also gather a lot of listeners.
Okay, great. And next question, runtime environments. Do you support running in a platform as a service such as Cloud Foundry?
Yeah, it's a good question. So we actually get deployed in the cloud a lot, and within the various platform as a service architectures or deployment architectures, I should say, or orchestration architectures. Yeah, as long as there's Java available to us in runtime, Ignite will run. And as I mentioned, the discovery protocol is fairly flexible. If multicast is enabled, it will use it. If TCP is enabled, it will use TCP. If there is some kind of storage or database is available, it can actually discover over a JDBC. It can discover over S3 storage. It can discover over shared file system. So cluster can discover in all sorts of fashion so various cluster members can find each other in all sorts of fashion. So Ignite will comfortably start in most of the PaaS offerings.
Okay, great. And can you disable the zero deploy feature for production?
That's a good one. We spend all this time actually making this feature, and then the question we get, can you disable it? But the answer is yes, of course. It's not the first time I'm hearing that question. It's a very cool feature in development, but not as useful in production, because you definitely do not want any magic, especially when it comes to security and financial deployments. So yeah, it's an easy configuration flag to disable it.
Okay, great. And now here's another comparison question. This time they're asking, how do you compare Apache Ignite capabilities with Hazelcast?
Well, I mean, we should probably go back a few slides since we're talking about DataGrids. Well, I want to go back to this slide where it says more than a DataGrid. So if you look at a Hazelcast, it's a fairly good product. It's an open source product. It's also licensed under Apache. It's not part of Apache Software Foundation like Ignite, but it is open source. But most of the features Hazelcast provides will have to do with DataGrid and some computations on top of that DataGrid. If you look at Ignite, we provide quite a few more components. We provide a full-blown compute grid, full-blown service grid, streaming, file system, et cetera, et cetera.
And actually, Dmitry, looking at that question, they're actually asking about Ignite DataGrid versus Hazelcast DataGrid. So maybe focus specifically on the DataGrid aspect.
Okay, I have a DataGrid slide for it. So one of the main differences between Ignite DataGrid and Hazelcast DataGrid, I would probably say that both support distributed data in memory, both support, both are distributed key value stores. I would say, and again, I mean, I have maybe not so obviously seen, but I do have somewhat of a bias towards Ignite. I'm one of the commuters, so take what I say with a grain of salt. I may not know everything about Hazelcast, but from what I know, Hazelcast does not have strong SQL capabilities for querying data, and Ignite does. So Ignite is fully, as I mentioned, fully ANSI 99 compliant. Actually, I think it's one of the few, if not the only product, in-memory product in the market that has fully ANSI 99 compliant queries for SQL. Generally, if you look at different products, you will get probably 1, 2, 3, maybe 5 keywords from SQL that you can use, and everything else is prohibited. In Ignite, you don't even have to think about it. Any SQL works. Another differentiating feature in Ignite versus Hazelcast, I would say OffHeat Memory in Ignite is available for open source users, and in Hazelcast, it's a closed source commercial component. So if you want to start playing with OffHeat Memory, Ignite probably would be, in an open source fashion, Ignite probably would be the only option. I'm sure there are some other differences, and probably if you ask Hazelcast founders, they'll tell you maybe slightly different story. But this from this what I hear from the users and from the community.
Okay, great. Next question. How long would it take to recover data in a failure ROI, return of information? Hopefully that question makes sense to you.
Recover data in a failure. So I'm going to assume we're talking about if a cluster member crashed, what would it take to restore that cluster member? So generally, you are able to configure multiple backups. And for instance, there's a primary copy within partition cache, but you can actually say that each primary copy has 2 backups. So overall, there will be total of 3 copies of data in your cluster for every key. And there's now no concept of a backup node. Every key may be backed up. If one cluster member A has keys 1 to 10, then key 1 may be backed up on cluster member B, key 2 may be backed up on cluster member C. So backups are also equally distributed within Ignite. And if one cluster member falls, the load that cluster member was responsible for will be equally distributed within the cluster. So that's the main reason for why backups are distributed. But essentially, if you have backups, then they will immediately assume primary responsibility in case of a failure. And in the background, Ignite will start rebalancing, transparently rebalancing the data without any loss of productivity of the system. So the system remains operational. You're still running transactions, you're still running queries. All the rebalancing happens in the background. Rebalancing is not free. It does take some network overhead. It does take some probably tuning. But Ignite has throttling for rebalancing. It has concept of delayed rebalancing, all sorts of optimizations you can put in to make it as transparent as possible within your application.
Okay, super. Okay, the next question here is, could you please give a real-world experience of using Ignite and how it improved performance?
Cool. Well, I mean, probably from that standpoint, I would say that Ignite as itself is a fairly young project, but it's based on many years of experience and battle testing of GridGain open source edition code. So probably about September of last year, GridGain has donated its open source edition to Apache Software Foundation. So Ignite 1.0 release is coming out probably Monday or Tuesday next week. It's right now constantly undergoing voting process under Apache and fixing comments that we get from Apache community. But probably the release will come at some point Monday, Tuesday, maybe at some point within next week. And that will be release 1.0. But if you take GridGain open source edition on which Ignite is based, I'll have many stories. For example, several banks actually deployed this code and were able to execute billion transactions per second on a 10-node cluster. It's actually a pretty cool use case when you have 100 gigabyte nodes and lots of processing happening on that data. So data is distributed. So you have close to a terabyte of data and lots of parallel processing happening on that data. And every so often, like within milliseconds, that customer wanted to update about a third of a cache. One third of a cache updated at such a frequency is a huge transactional load. And there you can actually utilize not only data caching, but a lot of collocation of data. With data, a lot of collocation of computation of data. And generally, you collocate compute on data to avoid extra network traffic. Instead of bringing data to your computation, you want to bring computation to your data. And Ignite has probably 20 different ways of doing so. So when you actually architect your system correctly, on a stable topology, on a stable cluster, you will have zero data movement. Only computations travel around. And whenever that happens, this kind of scale, this kind of performance is possible. So just think about it: 1 terabyte of data, 1 billion transactions per second on 10 servers. That would be a good example.
Excellent. Okay, thanks, Dmitry. And here's another question for you. Is there some special JVM that's required to set the off-heat bit to avoid GC issues?
Actually, we prefer the Sun or Oracle JVM, but it will work on OpenJDK as well. There is one issue that we addressed with OpenJDK probably last week that made it possible to use OffHeat on OpenJDK as well. So I would say probably no. You can work on pretty much any JVM out there. If you have any specific question about what JVM is supported or how do I do this or that within Ignite, there's a pretty cool support forum, community forum that you can get to from Apache, directly from Apache Ignite website. And I personally monitor that forum, and other members of the community monitor that forum, so you'll get questions pretty quickly, answers pretty quickly in regard to what's supported, how to get started, or how to configure certain things.
Okay, great. Here's another one. Is it possible to tier a partitioned cache and a replicated cache so that the client can achieve quick writes to the partition cache as well as full data replication? I hope that made sense. It's kind of a
I think the person asking that question is fairly knowledgeable in DataGrid, and it's very difficult to ask a question in one sentence. Let me actually say what. So partition caches allow for fast data writes. If you front them with local caches on the client side, then data reads become also fast. You can also have as many replicated caches as you like. So think about it this way: there's a local cache on the client, and any combination of partition and replicated data on the server. You can have as many partition and replicated caches on the server, fronted by a local cache on the client. In that sense, the client access becomes very fast as well. Clients in GridGain, in GridGain, old-headed. Clients in Ignite are actually have full API, and full API. It's not a limited client; it's a thick client. You can do compute from clients. You can do you can deploy services from clients, streaming. You can cache data. You can access caches from clients. I mean, they do not necessarily participate in caching of the data part, but the APIs are available to access the cache.
Okay, excellent. Here's another one. If I have data nodes in a remote data center, can I have client nodes locally for development? Can I have them communicate via SSH port forwarding or SOX proxy, or do I require a VPN?
Well, I believe the answer is yes, yes, and yes. So you do not require VPN, but you definitely can configure. For instance, if you want to work with Amazon Cloud, very easy to configure VPN and work with it in that fashion. It's supported with Amazon pretty much out of the box. But you can actually do port forwarding as well. We have it, we do it all the time, especially when we use management and monitoring tools and connecting from outside. A management and monitoring tool in Ignite is also a cluster member, and it also connects to the cluster. And it not all the time it has full connectivity capability, so we have to play tricks with port forwarding and VPNs and SSA secure tunnels, etc. But I would say that the answer would be yes, that's supported.
Okay, great. We've got time enough for maybe just a couple more questions. Here's a simple one. Can you manage remotely?
Well, yeah, actually, just mentioned this. I mean, there's a management and monitoring console available in Ignite, which is command line, but it's remote. You can connect to cluster remotely without being part of the cluster as a client. And you can check the live status of your cluster, how many nodes, what's the CPU load, what's being executed from command line. Or GridGain, from enterprise feature standpoint, provides a GUI-based management and monitoring tool as well, which also can connect remotely.
Okay, excellent. I'm just kind of scanning down the list here. Here's another one. Any memory leak problem with using OffHeat Memory?
Well, if you use OffHeat Memory, not really. I would say it's you're faced with it's entirely abstracted from the user. You're still working with objects. You never even know that underneath Ignite is utilizing OffHeat Memory. As I mentioned, it's a configuration switch. It's not a different API you write to. So if you're using Ignite APIs and your code does not leak, your personal code does not leak memory, I would say Ignite will not leak memory. However, you may actually want to configure maximum amount of memory that you want to allocate to OffHeat, in which case when that amount is reached, Ignite will automatically evict cold data to add more hot data in least recently used fashion. So the data that is least recently used will be evicted first.
Okay, great. You know, here's another one. What support levels do you guys provide with this product?
All right, that's actually not down my alley, but from what I know, we provide.
Let's go ahead and skip that one then. Yeah, you're right, because that's, yeah, let's go ahead and skip that one. Let me go on to this next one. But by the way, we will answer all these questions. Any questions that we don't get to in this call, we'll definitely answer them after the fact. But here's one more, and this will be the last one. How does Ignite handle unstructured data?
Well, that's actually a very good question. So there, in Ignite, the data is essentially unstructured. It's a key value object store. So you can store maps, you can store lists, you can store queues in memory, you can store strings, any JSONs directly in memory, and Ignite will handle them directly. So there is no special handling for you that would be required in handling of unstructured data. Ignite also provides a pluggable indexing. So if you want to index into some peculiar fashion into the unstructured data, you're able to actually add that indexing capability to Ignite. Again, it's yet another extension points, pluggable points that Ignite provides. And on top of that, if you look at GridGain, for instance, it also provides ability to change objects on the fly. So you can actually change class versions. You can add new fields to your classes, and the underlying server side will not have to be redeployed.
All right, excellent. Okay, well, thanks for all that great information, Dmitry. That brings us up to the top of the hour. I hope everyone got a lot out of today's presentation. As we sign off, I did want to remind you about the attachments that I had mentioned earlier, and also if you would be so kind as to rate the webinar and or leave any comments in the questions area. That'll help us improve the material for future webinars. Have a great rest of the day, and thanks again for attending.
Thanks, everyone.